What if I told you that the entire global economy, the phone in your pocket, the car in your driveway, and the satellites in orbit all depend on a single machine? A machine so complex, so precise, and so incredibly expensive that only one company on the planet knows how to build it. We often think of tech giants like Apple or Google as the kings of the mountain, but without a Dutch company called ASML, those giants would be building toys instead of supercomputers. Located in the quiet town of Veldhoven, ASML doesn't just make chips, they make the machines that make the chips. They are the ultimate bottleneck of the modern world. If their factory stopped tomorrow, human progress would essentially hit a brick wall. This isn't just a business success story, it's a tale of a 30-year gamble that paid off in a way no one thought possible. They aren't just a part of the future, they are the only reason the future is happening at all. Let's look behind the curtain of the most important company you've probably never heard of, and find out how they achieved a total monopoly on the cutting edge of human civilization. In the year 1984, the semiconductor world was dominated by giants like Nikon and Canon. Meanwhile, in a leaky, drafty wooden shed in the Netherlands, a small team of engineers from Philips and an assistant company called ASM were trying to stay dry. This was the humble birth of ASML. They had no money, no prestige, and their first products were, frankly, mediocre. They were competing against the finest Japanese engineering, and for a long time, it looked like they would lose. Philips, the parent company, kept trying to shut them down because they were losing millions of dollars every year. But the leaders of ASML had a different philosophy. Instead of trying to do everything themselves, they partnered with everyone. They realized that if they wanted to catch up to Japan, they couldn't just work harder, they had to work smarter. They built a network of specialized suppliers, turning themselves into an assembly point for the greatest minds in Europe. It was a desperate, high-stakes game of survival, where every year was a battle just to keep the lights on in that leaky shed. But through sheer grit and a series of clever engineering pivots, they didn't just survive, they started to innovate in ways the big guys didn't see coming. To understand why ASML is untouchable, you have to understand EU versus or extreme ultraviolet lithography. For decades, chip makers used deep ultraviolet light to carve circuits onto silicon. But as we tried to make chips smaller and faster, the light waves were simply too thick, like trying to write a novel using a massive house painting brush. The industry needed a finer pen. EUV was the answer, but it was a nightmare to create. EU light doesn't exist naturally on Earth in a way we can use. To make it, ASML engineers had to fire a high-power laser at a tiny drop of molten tin, twice, 50,000 times every second. This creates a plasma that glows with EUV light, but there's a catch. EUV light is absorbed by almost everything, including air. So the entire machine has to be a perfect vacuum, and the mirrors used to reflect the light have to be the smoothest surfaces ever created by man. If these mirrors were the size of a country, the tallest bump on them would be less than a millimeter high. It is a feat of engineering that borders on the miraculous, and for 20 years, everyone said it was impossible. But ASML kept pushing, spending billions on a technology that many experts thought would never actually work. By the early 2000s, ASML was at a crossroads. The development of EUV was burning through cash at an alarming rate. They weren't just building a machine, they were reinventing physics. To stay afloat, they did something unprecedented in the business world. They asked their biggest customers, Intel, Samsung, and TSMC, to become investors. Essentially, they told their rivals, if you want the future to happen, you have to pay for it now. Surprisingly, the giants agreed. They poured billions into ASML, effectively betting their own futures on this one Dutch company's ability to pull off a miracle. This was the point of no return. If ASML failed, the entire semiconductor industry would have stalled for a decade, and billions of dollars would have vanished. The pressure was immense. Inside the Veldhoven labs, engineers worked around the clock, solving problems that didn't even have names yet. They had to source parts from thousands of suppliers, each one a master of a specific niche. One German company, Zeiss, spent years perfecting the lenses, while others worked on the vacuum systems and the laser power. It was a global symphony of science, with ASML acting as the conductor of a very expensive, very risky orchestra. So, what does an EUV machine actually look like? Imagine a device the size of a double-decker bus, weighing over 180 tons. It contains more than 100,000 parts and over 2 kilometers of cabling. Shipping just one of these machines requires 3 Boeing 747 cargo planes. It is, without a doubt, the most complex piece of equipment ever sold to a commercial business. When it arrives at a customer's fab, it takes months to assemble and calibrate. A single EUV machine costs upwards of $150 million, and the newest high-NAND versions are expected to cost over $300 million each. But for companies like TSMC or Intel, it's a price they have to pay. Without these machines, you cannot make the 2nm or 3nm chips that power AI, 5G, and the next generation of smartphones. The machine works by projecting a pattern onto a silicon wafer with such precision that it can align features within the width of a few atoms. If you missed by even a fraction, the entire chip becomes a useless piece of rock. This is the heart of the modern world, a 3-story printing press that uses the light of the stars to write the future of humanity. Because ASML is the only company that can build these machines, they have unintentionally become the most powerful player in global geopolitics. We are currently in a chip war. The United States and China are locked in a struggle for technological supremacy, and ASML is right in the middle. The US government has pressured the Dutch government to restrict ASML from selling its most advanced EUV machines to China. Why? Because whoever has the best chips has the best AI, the best weapons, and the best economy. ASML CEO has often expressed frustration with being used as a political tool, but that is the reality of being a monopoly. They are a private company with the power of a sovereign nation. China is currently spending billions of dollars trying to replicate the technology, but they are finding out that you can't just buy your way to the top. You need 40 years of institutional knowledge, a network of thousands of highly specialized suppliers, and a level of precision that is nearly impossible to copy. For now, the gate to the future has one key, and the Dutch are the ones holding it. This puts ASML in a position of incredible influence, but also incredible danger as they navigate the shifting sands of international relations. As we look ahead, the challenge for ASML only gets harder. Moore's law, the idea that the number of transistors on a chip doubles every 2 years, is reaching its physical limits. Atoms are only so small, and we are running out of room. But ASML isn't done yet. They are already working on the next generation, high numerical aperture EUV. This will allow for even finer resolution, enabling chips that are even more powerful and energy efficient. The stakes are higher than ever. Every new generation of technology, from self-driving cars to personalized medicine, depends on ASML's ability to keep shrinking the world. They have moved from a leaky shed to a company with a market cap of hundreds of billions of dollars, but their spirit remains the same, a relentless, almost obsessive focus on solving the impossible. They have built a moat that is wider than any in history, not through lawyers or marketing, but through pure, unadulterated engineering brilliance. As long as we crave more computing power, we will remain dependent on the specialized machines built in a small town in the Netherlands. We are living in a world designed by many, but built by only one. The story of ASML teaches us a vital lesson about the modern world. Specialization is the ultimate competitive advantage. In an era where every company wants to do everything, ASML chose to do one thing, the hardest thing, better than anyone else. They didn't try to compete with their customers, they made themselves indispensable to them. Their success wasn't built on a single eureka moment, but on decades of incremental improvements, massive risks, and the courage to fail for 20 years before finally succeeding. They prove that true innovation requires patience, cooperation, and a willingness to invest in the extreme long term. Today, ASML stands as a testament to human ingenuity. They remind us that the most powerful entities in the world aren't always the ones with the loudest voices, but the ones who solve the problems no one else can touch. As you look at your screen right now, remember that its existence was made possible by a machine in the Netherlands, firing lasers at drops of tin, 50,000 times a second. The future isn't just coming, it's being printed, one atom at a time, by the only company that can. That is the legacy of ASML, the silent architect of our digital age. I hope this deep dive gave you a new perspective on the strategies and the relentless mindset behind these global icons. If you enjoy deconstructing business empires and tech legends in this tech archive style, make sure to hit that subscribe button and turn on all notifications. That way, you will never miss a new blueprint of history. For those of you ready to explore more boardroom coups and technological breakthroughs, I have handpicked 2 videos for you right here on the screen. Click one to keep watching. I will see you in the next one. Thanks for watching.